right, so welcome back. Welcome to this afternoon session on the impact of AI, I would say, on scientific research. And as you have probably recognized, we have chosen quite broad titles for this session so that everybody can anticipate maybe something different. But in preparation of this session, I just wanted to find a concise definition of what is science, by the way. And Wikipedia tells us that science is a systematic discipline that builds and organizes knowledge in the form of testable hypotheses and predictions about our universe. Okay, and I think this definition reflects two things we might want to discuss in this session. The one way is how AI influences the way we organize science in our scientific progress, in maybe also in the way we organize conferences. But on the other hand, I think it's also interesting to discuss the way AI changes the nature of the results, of the scientific results we have. So far we always thought about that we have a model of the world, but now with deep learning methods, sometimes not so obvious anymore how to interpret the results these models deliver for us. Okay, we will first have a talk by Noshir Contractor, then we will have a panel discussion. I will introduce the panelists then, but let me just say a very few words about Noshir. So he's Professor of Behavioral Sciences at Northwestern University. So he means that he is working in network science, and he is fellow of several associations. I don't mention them all, but among them is also the ECM. And just maybe and he received several awards. And since May 2024, if I'm not mistaken, he's also he's director of the Web Science Trust. And we are very happy, Noshir, to have you here again, and we are looking forward very much to your presentation.
Thank you, Stefan. Thanks again. Thank you. First of all, thanks to all of the, oops. This is moving the mouse. Is there a way in which this doesn't move the mouse on its own? It's like a magic. I do this, the cursor is moving on my screen.
You can use it as a pointer.
I can use it as a pointer, okay, but I don't want to use it as a pointer. It looks like it's a fly going all over my screen all the time there. So, first of all, thank you again very much to all of the organizers of this conference. This is such an incredible opportunity to talk about an important topic, and the range of discussions we've had and the quality of the ideas that we have exchanged out here will certainly be something I will take back with me, and I hope as many of you will as well. So I'm going to focus, as Stefan pointed out, on the impact of AI on scientific research, and broadly I call it two paradigm shifts with a question mark, because as was mentioned by Stefan, one is, have we changed the object of scientific inquiry? To what extent has AI changed what we study? And then the second is, how has AI changed how we study that? And so I call that the object of scientific inquiry and the conduct of scientific inquiry. I'm going to do most of my presentation on the latter, but I will start briefly on the former, especially as it applies to those who are interested in looking at social systems. So back in 2009, along with several other colleagues, we published this very small essay in Time magazine titled Computational Social Science. We had no idea at the time, when we wrote this article, that this would become a pretty much well-cited landmark article that was used extensively since then to study social systems. And our argument there was actually quite simple, that because of the web, we again had now the opportunity of instrumenting a lot of our social interactions in ways that we were never able to do before. And as a result, the web was both a way of studying social systems, but also a way of studying how the social systems are impacted by the web. And so this article was in 2009. It gave rise to a lot of different movements in the area of computational social science. And again, right about 10 years later, we went back and wrote another forum in Science, again, this time titled Computational Social Science, Obstacles and Opportunities, to take stock of where we were and to also see where we were headed in the future. Obviously, that decade had brought a massive amount of change in the ways in which we thought about computational social science. More importantly, from my point of view, we also published an article in Nature in 2021, which was called Measuring Algorithmically Infused Society. And it was a recognition that until now, we thought about the web and technologies as things we used. So all we had to study were human beings and the ways in which we were using technologies. But as you all know, that has changed. Today, what we see, what we read, what we do, what we buy, what we watch, is all algorithmically infused. Algorithms which, for the most part, are black box to us and change at the whims of the platform providers. As a result, the study of social systems as algorithmically infused societies has made social science much harder science than it was previously. Having had a background as an undergrad in electrical engineering, I was always the person who would say, oh, there's the hard sciences and then there's the soft sciences. I'm convinced today that we have the hard sciences in engineering and computer science, and the social sciences are the harder sciences, and just made even further hard by the notion that we have an algorithmically infused society. So in this article in Nature that Claudia Wagner took the lead on, and I was part of the team that wrote it, the subject of investigation has changed. So what we study has changed, the emergence of these societies, and it applies to all facets of our life, whether it's social process, are infused by algorithms on the left. If it's political process, we certainly have seen that again being infused by algorithms. Whether it's economic processes that are also being influenced in terms of recommender systems and what we buy and what we choose to watch. So all of this to say that today, the challenge of what we study from a social system has also changed as a result of AI, and we're only just seeing the beginning of that. An example from my own research is by looking at what we call human AI teams. In the past, we looked at technologies and even AI as an assistant or a tool. Think about Siri, think about Alexa. But today, as Tom Malone at MIT has said, that AI has now become a teammate, and in many cases has become our manager, directing different members to go do different things. There's a lot of work done by Michael Bernstein and his colleagues at Stanford, where they talk about flash teams and flash organizations, the ability of using computers to put together teams that may involve humans, but may also involve AI agents at the same time. And that is a big mindset change for us to think about our workplace of the future. We found all kinds of things in this area. I will not bore you with the results. Clearly, just adding a teaspoon of AI to a team doesn't make the medicine go down any better. It becomes much more complicated. We've seen many instances where adding AI actually is worse than not adding it. There was a study that showed that radiological diagnosis was done better by either a human or an AI, but done much worse by having a human and AI work together. So again, the notion of simply adding human and AI together in and of itself is not going to be able to solve the problem. So we really have to think about ways in which we advance the synergies. And so this is an example of a project that we are working on, funded by Microsoft and by the Army Research Lab, where we think about what role is the AI playing. Is the AI somebody who is going to provide group facilitation, management? Is the AI going to be someone that provides content issues, et cetera? And we're still at early stages. So one is called a coach AI, the other is called an assistive AI. And what we find, and this is the preliminary results, is that in contrast to perceptions of human teammates, we really don't like AI to tell us group facilitation. We don't like AI to tell us, oh, I haven't heard from you. Can you say something? Oh, look, we only have 10 minutes left. Can we move on? We are much more happy having a human tell us that, but we are very happy to have the AI give us content-based suggestions. Again, these are preliminary studies, and they may change. Another very interesting study is that in the world of management, we have often noted that we, as human beings, have a real problem with what we call as competent jerks. So people who are really competent, but who are jerks. And we try to avoid them as much as possible. There's an article by that title in Harvard Business Review, Competent Jerks and Lovable Fools, and the role of social networks in who we go to. It turns out that when it comes to having AI, humans are much more tolerant of having an AI that is a competent jerk, and they have no problem working with an AI that is a competent jerk as compared to a human. So maybe there's a lesson there to be learned about how we might be able to use AI in some contexts. As I said, I'm going to focus most of what I'm going to talk about on the second paradigm shift, the shift in the conduct of scientific inquiry rather than the object of scientific inquiry. And I put these three pictures on the slide to tell you what I'm not going to be talking about. We've already heard enough, both in this conference, but also more generally in the media, about the amazing ways in which AI has changed the way we do scientific inquiry, whether it is AlphaGo, whether it is ProteinFold, whether it's GNOME. These are all absolutely spectacular ways in which AI has fundamentally changed the way in which we do scientific inquiry. But I'm not going to talk about that. I'm going to talk perhaps about much more mundane things, about how we could think about the ways in which all of us, in all of our research, even if we are not at that level, can start reimagining what it means to do science. And for that, I'm going to actually take us on a bit of a detour. I'm not a historian. We've had good history lessons here. I'm not one of them. But I'm going to take us on some lessons we have learned when we as a society have been confronted with technologies in the past. And the reason I want to do that is because it tells us, provides us a framework to see what it is that we are doing with AI right now when it applies to science, and also to be mindful of not making some of the same mistakes we have done in the past in misinterpreting how we think about the impacts of technology on society. So when I was in grad school, one of the first things I was introduced to is this notion of how we think about technologies in general. There are some amongst us who are the utopians. These are the people who think that technology is an unalloyed, oh my goodness, what's going on here? Something has taken over my... Okay, let's just call it a utopian. So a utopian is somebody who believes that technology is an unalloyed blessing. Everything is going to be great, as was discussed today. If technology creates problems, if ChatGPT is going to use too much of energy and challenge our climate, AI will find ways to take care of that climate. So it's always this thing, the optimism that if technology creates problems, it's going to solve the problems it creates. One of the things that I like to remind colleagues is that as an engineer, when I was often told that if you want to solve the world's problems, go get an undergraduate degree in engineering or in computer science. And if you want to go get a master's degree or PhD degree, then the reason to do that is to try to solve the problems created by the computer scientists in the first place. So you need both of these in order to be able to continue to work in this area. The dystopian, on the other hand, is the person who believes that technology is an unmitigated curse. It's the opium of the masses. We don't use technology. Technology doesn't depend on us. We depend on technology. We continue to do that. A third approach tries to seem quite innocuous by saying, oh, it's neutral, it's not going to change anything, it's not good or bad. And I think that that's very misleading, because the fourth approach that I argue is the most valid in this case is that technologies, including Gen AI, are having both positive and negative effects at the same time in spite of each other. And trying to think that it's neutral is extremely naive. So we can go back to the telephone. The telephone was very important in helping create all kinds of new industries and professions. It gave a new name to the oldest profession in the world, being called call girl, because the telephone was used to make the phone calls. But it also improved all of the enforcement that was done by the police in terms of being able to deal with issues that were considered illegal at the time. And there are many, many instances of almost any technology that you can see having these dual effects. So the ways in which we think about this is important to see how these come about. Our first instinct is that we use a technology as a substitute for doing something. A substitute for doing what we already do. And let's start thinking about how this applies to the ways in which we're thinking about how we use Gen AI. There's a lot of work done in the adoption of innovations by a person by the name of Everett Rogers, who's passed on, who talked about diffusion of innovations. And he said, in order for an innovation to be adopted, it needs to meet 5 criteria. Relative advantage, you can see something that it's doing better than what was being done before. It should be easily observable. You should be able to adapt it, customize it. It should be compatible with the previous way in which you did something. And then finally, it should be easy for you to try without having to invest a lot of money. Think about Gen AI and see how easy it is for us to see the relative advantage that it provides over something before that. The extent to which we can immediately observe the effects. We're able to adapt it thanks to prompt engineering. We see that it's compatible because we do it on our existing browsers. And finally, it's trialable because everyone wants to give you a freemium account. So you have all these benefits that makes it so easy to understand why the adoption has been there for something like that. The same arguments apply to the automobile, to the telephone, to video conferencing, the ARPANET, the internet, and the World Wide Web. All of these had those benefits that made it much easier to adopt those technologies. Of course, with the dawn of Gen AI, we see a lot of these same kinds of technologies that have a lot of the same kind of features that I was just describing to you. There's a problem, though. Substitution often works on the wrong assumptions. Take an example from history. This is the telecommunications transportation trade-off. When video conferencing first came on the scene, everyone who wanted to sell you, at the time, a fairly expensive video conferencing product said, hey, you know what? Spend that money on our video conferencing equipment because you won't have to travel as much. So your travel budget can go down, and then you'll offset that by what you spend on video conferencing. The graph on the right is what actually happened. That the more people actually began to use video conferencing, the more they traveled. And the reason is because video conferencing created opportunities for us to think about doing more things together. And what that meant was that we were not looking at the technology as a revenue saver, but as a potential revenue generator or to improve what it is that we are doing. I say this because at this point, a lot of us are thinking of Gen AI in general as a substitute that's going to save us something. We're going to be able to get things done more quickly. Whether it is your report to the provost's office about a vision at the university, or whether it's an undergraduate student who's trying to get by with getting an assignment done at the last minute, we think of it as substitutes. What we don't think about is what happens at the enlargement phase. Most of you are not old enough to remember ever using a typewriter. I am. And when we switched to a word processor, one of the first exciting ways in which everyone described the word processor was, oh, it's like a typewriter, but it has an erase button that makes it so much easier. And that was the hook. That's why I adopted the word processor. That was my primary reason for doing it. And then what happens? Oh, I'm going to save all this time because I'm going to get my drafts done so quickly now. Really? How come we continue to work on it much more as a result of that? So we enlarge it. We spend much more time working on these drafts until the very last minute. In fact, the word draft is anachronistic. It applied to the typewriter where you actually had a physical draft and then you had a second draft. In the world, in word processor, we use the word drafts, but that just basically means when I decide to save my file or auto-save the file. These are ways in which we need to think about what we are doing with Gen AI. We're doing a lot more of it than what we did previously. So whatever benefits we thought we were getting from substitution, we have to consider how much of that is really based on enlargement. And we are used to looking at enlargement in other areas. Think of the ways in which some things got adopted. Electricity took 46 years to reach a quarter of the US population. I'll let you read the rest of the stats, but you come to TikTok and we were, wow, 3 years in 2020, and it reached a quarter of the US population. ChatGPT did better than that in less than 2 months. So again, you see that not only is the space increasing, but it's increasing at that exponential rate that we have to begin to fathom, and how many people are coming on board to do these things. We've all seen, those of us in computer science know about Moore's law, computational power doubling, Metcalfe's law, the value of a network proportional to the number of users squared. But we still have trouble thinking exponentially. How many of us realize that after 30, if you're looking at one adopter for an app, one adopter, and you say after 30 days you have about 1,000, if you double it every 3 days, that doesn't seem a lot, just double it every 3 days, okay. After 30 days you have 1,000. You go 30 days longer, now you have 1 million. You go 30 days longer, now you have 1 billion. That's the way in which our mind has difficulty understanding exponential enlargement, exponential growth, as we look at these different phenomena. We all know what happened to the IP4 and what's happening now with IP6 and what's happening because now all of a sudden we are beginning to think about everything on the internet. Every single device that we have is on the internet, including my favorite, my egg tray in the refrigerator. Right? It's internet enabled. At any point, I can tell you exactly how many eggs I have in my refrigerator and how many of them are more than 4 weeks old, for example. It gives me all of that detail information. That means we are now enlarging the ways in which we think about this. But one of the things that happens with enlargement is we get excited and say, everyone is benefiting from the enlargement. We're all doing better. All over the world, we see things happening. True, but there is an information gap that is actually increasing, because the haves are benefiting a lot more than the have-nots. And this is something that we have to keep in mind at a much more macro level as we think about the ways in which we're doing that. Even within the scientific enterprise, I would submit that people in this room who are coming from elite institutions are going to have a much better advantage using Gen AI than those who may be in Rwanda or in Ghana or in other parts of the world where they don't have as much access. Yes, they may do better than what they're doing now, but the gap between the haves and the have-nots is going to increase. And it's something that we need to think about as we look at the scientific enterprise in this context. The ultimate story is that even when you have all the substitution, all the enlargement in the world, you still find that you have no benefits in productivity. It's called the productivity paradox. This was something that Robert Solow talked about technologies in general, the Nobel Prize-winning economist. He said you can see the computer age everywhere but in the productivity statistics. In fact, that same sentence virtually also appeared in a more recent chapter by Eric Brynjolfsson and his colleagues, who said, we see the effects of transformative new technologies everywhere except in productivity statistics. And then he goes on to say, past surges in productivity were driven by general purpose technologies, GPT. The other way in which we think about GPT as compared to what we are talking about in this context. But in fact, the examples he gives are very illustrative. Things like electricity, things like the internal combustion engine. And some have made the argument, as has been discussed at this, that what we are seeing now is Gen AI being an example of a general purpose technology. And that may be some of the ways in which we do it. But notice it says, these technologies require complementary co-inventions, whether it's factory redesign, highways, business processes, and workforce skills. And this is one of the reasons why we need to think about that final stage, and that's called reconfiguration. If we try to think about doing Gen AI and using Gen AI for the purpose of doing scientific research and doing it only as a substitute for what we are doing, or doing more of it, enlargement, we are probably not going to see the payoffs that we hope. The real payoffs are going to be as we reimagine the ways in which we use Gen AI to reconfigure the entire scientific enterprise, not simply to serve as a substitute or to serve as an enlargement. There are benefits to that, I don't deny that. But that's not where the real payoff is going to come. And in fact, that's one of the reasons why, if you look at examples from the past, the automobile didn't really take off till we had a whole highway system. Otherwise, we were going to use the automobile to go to do our grocery shopping or go to the church twice a week or 3 times a week rather than once a week. But when we brought the entire highway system into place, that reconfigured what we think of as trade, commerce across the entire country. The same thing was true when the ARPANET was originally one that we geeks would use to exchange email or share resources. And then when it became this commercial venture that is now much larger than what it was. And the same thing has been true also with the World Wide Web and so on. Which is exactly why I think we should not forget Amara's rule. We overestimate the effect of technology in the short term and underestimate it in the long term. And I really encourage us as scientific researchers to think about going beyond that substitution and enlargement phase. So I'm going to wrap up here by talking about a few examples that I see, and we can debate how many of them are really just substitution and enlargement, and how many of them are really reconfiguration. Okay, so I'm going to rapidly go through some examples here. So, in general, we can think of AI in research as a clerk, a colleague, and a coach. So this is Andrew McAfee's distinction, which I think works quite well in most cases that we are looking at. There's an article that was written, this is in the National Bureau of Economic Research, which is one of the most prestigious publishing outlets. It says they have a stage model where you can look AI for questions in literature, for hypothesis, for wording and instructions, for code and documentation, and for simulation and code audit. This article it's a very long article, but it talks in details about ways in which Gen AI can actually contribute at each stage to the scientific process. Here is an example of an article that focuses on AI and hypothesis generation. Can GPT be used to generate scientific hypotheses? And it says it does, while the error rate is high. It talks about a swarm of hypothesis machines that can be challenged by automated experimentation and adversarial peer reviews. So you begin to see people thinking quite differently about how we can come up with hypotheses and use Gen AI to ingest as much of the existing literature and potentially suggest it, not always well, hence the error rate being so high. We talked earlier today about the difference between prediction and causality, and we talked about Judea Pearl's work and so on. This is an article that was covering a story written by the Stanford Social Innovation Research, which talks specifically about the case for causal AI and points out that a lot of the ways in which we are using predictions that are made by AI to intervene in policies about it actually get it absolutely wrong, such as trying to understand the effect of the costs of healthcare costs upon future ways in which the people get treatment for it, etc. Turns out that the effects are exactly the opposite amongst whites as opposed to African Americans. And that's not something that you can tease out by just looking at the prediction models. Here's another one in hypothesis generation, again, using both language models as well as causal models and causal relationships and causal graphs that are being used, again, to build hypothesis generation. I already mentioned this one. Can AI serve as a substitute for human subjects? Who thought that we could now replace going to people and talking to them and instead create a version of that person online, a synthetic version of you, and use that person as a potential subject? The first question comes to mind, how do we know these people are reliable, etc.? There are articles that talk about how, in fact, it can be used. This was one that used it for helping software engineering projects. This one replicated experiments to see how well we could be responding as compared to what actual human beings were responding. And they said that if you are able to train these models, in some cases they can do a pretty good job of mirroring human responses in certain experimental contexts. This article, which came out before the elections, it was published last year, showed how actually people can sometimes be more honest when the AI agent can be more honest when answering a survey question than the human subject themselves. In social sciences, we talk about socially desirable responses. And a lot of the debate about the elections and why the opinion polls for the last several elections have not done well in the United States, at least, is because they believe that the human respondent often tells the person asking the question the answer they think that person wants to hear. But that's different from what they will actually do once they are behind the polling curtain, so to speak. And this again shows that in some cases there are ways in which you could create a more honest response by going to a synthetic version. Again, as you can see, it was not successful at anticipating demographic level differences. These are not ready-made solutions, but I'm just allowing us to think about what might be and what we need to be cautious. This is a website called Synthetic Users, and they have all these different studies that they report done on people with different synthetic studies, all the way from large language models to simulate patients for training mental health professions, simulating the human in human-computer design, language models, simulated economic agents, and so on and so forth. This was a study of switching from the study of actually getting the data. We started with hypothesis, then we talked about how you get the data. This is about how you actually get reviews done. So AI as a manuscript reviewer. This article claims that articles that are reviewed, all of us get reviews and we decide to put it into ChatGPT or rather than doing it ourselves. Turns out that people did a systematic study of this. They detected which ones were more likely to be Gen AI reviewed and found that those tended to have more positive language and gave slightly higher ratings, which is not necessarily a good sign, but the fact is that people are using it enough where people can conduct these kinds of quasi-experimental studies. Some of them are saying that they use it for meta reviews. So in many of our fields, a reviewer gets a meta review as the person who's supposed to synthesize reviews. There are a lot of people who are, again, now using this to create those kinds of meta reviews. That said, there is also a lot of journal policies that are opposed to this. So guys, this is about JAMA, the Journal of American Medical Association, and the network of journals that said it precludes the inclusion of non-human AI tools as authors and requires transparent reporting of use of such tools. Submission and publication of clinical images created by AI tools is also discouraged unless part of the formal research design or methods. Similarly, this was, again, an article that talked about how AI is facing pushback in the review process from the NIH, which prohibits it completely, and others that are also looking to see how even the journal Science prohibits the use of LLMs during peer review and prohibits reviewers from uploading manuscripts to the Gen AI tools, partly because of privacy issues, because many of these Gen AI tools are now then being used also to train further models. And the Lancet is another example of that. Finally, we get to research dissemination. So this is the part where we say we've got the article published. How do we use AI now to make that visible? We publish an article and then we stop at that. Gen AI is being used increasingly now to be able to set up an interactive chatbot. Imagine having a chatbot for your article where somebody who is a student is able to query it and question it and ask and have a dialogue with it as it goes along. There are people who have used virtual reality where they publish an article about in AI, in application in quantum optics, and allow people to interrogate that model. And then finally, actually, one of my colleagues, Nick Diakopoulos, and his team have worked on taking the research that they did and creating a simulated policy impact where they can actually see how a particular scenario, but I think I may have, on the next slide. This is a transparency policy for Article 50 of the EU Act. And he was interested in seeing how they could generate scenarios and narratives to see how people would react to these policies. And this becomes a new policy tool where you can be reliable that the text that was generated was scenarios looking at different ways in which what is the effect of transparency legislation in terms of mitigating harms in areas such as labor and well-being, which it does, but is not so effective in areas such as social cohesion and security. So there's another one here, how AI enhances perceptions of scientists. This was a very interesting study. They looked at PNAS articles. They took the normal summaries, the significant statements of PNAS, and replaced it for a sample group by creating a ChatGPT version of that. And they found, guess what? That in general, the ChatGPT version was simpler to understand. People liked it more. Interestingly, they had more favorable perceptions of scientists. They were perceived as more credible and trustworthy, but less intelligent than more complex written human PNAS summaries. They were able to comprehend scientific writing better after reading a GPT summary, and they actually summarized the research better when they read the GPT summary as opposed to the significant statements that was laid out in the PNAS article itself. So to wrap things up here, I took the liberty of actually showing how we could even use it to generate synthetic videos about events such as this. So, let's see.
A paradigm shift in computer science? This workshop focuses on the challenges for computer science and the sciences in general, the move from logic and algorithmic certainty to probability and LLMs.
So this is an example of how we could have used it to help promote this particular event. If you want a little longer overview, and I won't play the whole thing, but I'll play a little bit more.
Welcome to our engaging video on the upcoming event, A Paradigm Shift in Computer Science. Join us as we explore the challenges and opportunities in computer science, focusing on the transition from logic to probability and LLMs. The workshop will delve into the impact of AI and machine learning on society, sparking intense public debates, and the philosophical insights it offers. The impact on scientific research and the role of universities in a platform-dominated world will also be explored. The event is organized by the Faculty of Informatics at TU Wien and the Institute for Human Sciences. It is supported by various organizations.
Okay, so the point being that this took me about 5 minutes to do yesterday. So it gives you an idea of how we could. Now, is this a case of substitution, enlargement, reconfiguration? That depends. One last one. I don't know how many of you have played with Notebook LM. A couple of you have. So Notebook LM is another great way where all I did is a Google tool. I put the two files that I put in here with the agenda and the list of people here. Those are the two PDF files that I created from the web. And then what I did was I went in there and went to Notebook LM. And then when you go there, you can have a notebook guide. You put that in there. Now this will take a second to load, but it'll load there. It creates a study guide. It creates questions. It creates an exam. It creates a briefing documentary. And then it also creates a podcast.
Welcome to our deep dive. Today we're looking at some pretty thought-provoking stuff you sent over about this workshop at TU Wien, a paradigm shift in computer science. It really seems like you're trying to get a handle on, like, the future of the whole field.
Yeah, it looks like you went deep on this one. You've got the program here, speaker bios, background info, quite a stack.
Well, the title itself kind of grabbed me. Paradigm shift. That's not something you hear every day. And when it comes
Guard of artificial intelligence, think of it like trying to teach a computer to think like Spock.
Wild idea that AI isn't just changing computer science, it's changing how we do science, period.
Yeah.
Like the whole shebang.
It is a pretty radical thought, and the workshop really dives into this head first. Day 2 kicks off with the impact on scientific research. The themes was that even with all its power, AI still can't truly replicate those uniquely human qualities.
Like what specifically?
Ironic.
Well, think about things like creativity and critical thinking. AI is amazing at pattern recognition.
So I just wanted to show that, these are all things that are also part of the scientific process and something that many of us are not very good at, taking our research and making it available to the public or promoting it in certain cases. And so I think these are also things we want to continue. This was one last closing slide I have here, pretty much closing slide, is can generative AI improve social science? For those who are interested in this was an article published in PNAS by a good friend of mine, Chris Bale, and he really goes through and documents in all the different ways how it can help with survey research, online experiments, content analysis, agent-based models, lit review, novel research questions, routine research tasks, writing, data cleaning, soft program. But then he also talks about the limitations, right? Bias in the data used to train these tools was mentioned today that it's only as good as the data that it was given. And in fact, we found many studies that sometimes, one of the studies we looked at, people's perceptions as perceived by the AI agents on the Ukraine war was different because the model it was trained on was about 1.5 years old as compared to where we are now. And so these are continuing important things. But I think what the last sentence is what I want to leave you, and that is the need for increased collaboration between social scientists and AI researchers. So 3 takeaways. AI won't replace scientific researchers, but researchers with AI will replace researchers without AI. Collaborative intelligence in terms of what we want to do, where we need people from CS and AI and people who are domain experts to go along with AI as part of the teams that we need in this area. And last one, that is, are we still really in a paradigm glide, to use Moshe's word for this morning, where all the examples I gave, you may argue, are just substitution and enlargement, where we already do it. Are we doing something different? And at what point can we go into the paradigm shift? Thank you so much.
Thank you very much. So sorry, it's me again, not such a nice avatar. So, yes, damals in die Mitte. Ich wollte es gerade machen, Hannes, ich habe das schon antizipiert.
Aber ich bin auch ein Ingenieur.
Ja, das habe ich auch antizipiert. Thank you, Hannes.
I'm a bad engineer.
You thought that was a virtual glass, but it was an actual glass. That was physics.
Okay.
You can't deny it. But do we want to put this in the middle? I think you want to put it in the middle, right?
I think Hannes is now hesitating to.
No. This is
Yeah. So we keep on your shoes. That's important.
We'll keep our shoes on.
That's important. Okay, so thanks again for a very inspiring talk, having a quite generous perspective on technology and the impact and then on our current topic, and also for telling us also a little bit about how AI impacts social science. And we have now 2 panelists which, so to say, with also different background. And let me just very briefly introduce them. Left to me is Georg Dorffner, professor at the Institute of Artificial Intelligence, Center of Medical Data Science, Medical University of Vienna. So he is, I would say, one of the pioneers in AI research in Austria. Already in the 80s worked on neural networks. And what else can I say? I have so many things here. Yeah, he's also curriculum director of the master program Medical Informatics at the Medical University of Vienna, and he's vice president of the Austrian Society of AI. And left to Georg is Günter Klambauer. He's professor for artificial intelligence in life sciences at JKU Linz. He has a background in maths and biology, but then moved to machine learning. And for his, I think, was it for your thesis, you've been awarded with the Austrian Life Science Award and the Award of Excellence of the Austrian Ministry of Science. And his current research focuses on the development of deep learning and AI methods for use in life sciences. And yeah, without further ado, I would maybe hand over to Georg first.
Yeah. Okay, thank you very much, Stefan. Thank you very much for the introduction. Also, thank you very much for the invitation. I also find this a very fascinating workshop. I mean, you said, I wouldn't consider myself a pioneer of AI. I give that credit to other people like Robert Truppel or Georg Gottlob. But I was one of the first in the 80s to do neural network research, and it wasn't considered AI. Couldn't publish at AI conferences, and it's very fascinating for me to see the latest development. And also, I was involved deeply in the discussions about symbolic and sub-symbolic in the 19th. So I really appreciate all the discussions here. But now also thanks to Noshir for your very nice presentation. There's certainly nothing I can disagree with. So I thought if you allow me, I can take a few of your things a little further. So one thing where I think AI or Gen AI might lead to a reconfiguration, as you called it, is the way we publish or the role will publications play in future. I mean, as a curriculum director, I'm involved a lot in our discussions of how much should we allow our students to use ChatGPT or others in writing their thesis, and the check of that is in the hands of the plagiarism check. And my argument has always been we're in science. I mean, humanities are a different thing. In science, we overemphasizing the importance of plagiarism, because what's important is the study result. Like in medicine, we conduct a study, the results, but we have put so much focus lately into the prose we write about it, and we're it created an absurd situation. We all are forced to write in our own words. Even self-plagiarism is missing, and then other people do systematic reviews, as you mentioned, and they have put a similar effort into deciphering our prose into what it means and what the paper has in common with the other paper. Now these tasks are frequently replaced or used for that. Gen AI is being used for writing the paper and for interpreting it. So one might ask, I mean, if in future the prose of the paper is generated and then another Gen AI interprets it and does further research with it, in the end, who will need the paper actually in the middle? Wouldn't it be more efficient to sort of bypass that and focus more on the actual study results? And there, I think we generally definitely will have a generative effect. We will be able to do more research, more studies, because we have AI as a tool. So be interested to hear your opinion about that. And the other point I would like to mention is, you said in the end, AI will not replace scientists. I mean, some people think it will. My argument why I think not at the moment, and that comes back to the general theme of the last 2 days. I mean, what can LLMs do and what they cannot do? I mean, what I think still, even though they changed my mind, with respect to AGI, I definitely think it's sooner than 40 years, as we heard today. Before ChatGPT, I would have said I won't live long enough to see it. But what they're still lacking is what we called in the 90s grounding, symbol grounding, situatedness, embodied method that was alluded to by Eric Prem. So I don't think they fully understand what they're talking about. They need, and also earlier today, so it was mentioned, science is about not trusting one's senses. LLMs don't have a sense that they can either trust or mistrust. So I think the next big step will be, or should be, or can be in future, the next big breakthrough in AI will be when LLMs become multimodal models. I mean, already now ChatGPT can deal with images, but other senses, and only then I think they might reach a level where they do what a scientist do, because now they can create hypotheses, write about this thesis, do the analysis, but they don't have the creativity of interpreting what it means and then coming up with new concepts and new ideas. So that's I think, but that might change. One or two breakthroughs might turn them into systems that eventually will be able to do something like a scientist. So that's my personal opinion, and adding to this, and I'm certainly interested to hear your thoughts about it.
Okay, thank you, Georg. Maybe we pass over the mic to Günter, and then Noshir, you have the possibility to react.
Yeah.
Remember more than
Yeah.
Go ahead.
But yeah, Noshir, very great talk. It reminded me, or a lot of your thoughts sparked something in me about my own research and so on. The one first thing that occurred to me, and the story that I wanted to tell, is also when you showed the first video and the AI assistant said, this workshop delves into the topic of blah, blah, blah. There's a very funny story that happened in science, actually. So this word delve is quite unusual, right? So suddenly from November 22 on, it appeared more often in scientific abstracts, and then people looked into it. So before November 2022, less than 0.1% of the abstracts contained the word delve. But then suddenly, from that on, I think it more than 100-fold
Really?
of the abstract, so it went up from 0.0 something to 1% of the abstract contained the word delve, and this is because ChatGPT likes this word. So also GPT has its own, and that's why we also can determine with other systems whether something is AI written or not, because it has its own characteristics. So don't use the word delve in your abstracts. No. Yeah, I think there's a lot of things that we can discuss. Also, hopefully we get to hear some inputs from the audience. Just a second thing. So the first thing was this that struck me. So there's still ways, of course, you can recognize things also in the review process. I'm myself submitting to iClear and having these discussions whether something is AI generated or not. Second thing is that kind of what you said, you won't talk about like AlphaFold and so on. So for the audience, this is unfortunately AlphaFold is not from my group, but this is the rough area in which my scientific work happens, so artificial intelligence in life sciences. And this AlphaFold is just got the Nobel Prize, or half a Nobel Prize, and it completely changed the way molecular biology works. So to find the 3D structure of one protein that is now what is predicted within seconds by AlphaFold, often that was a team of 5 researchers working for 2, 3, 10 years to resolve the 3D structure of one protein, and this is done at almost experimental quality by AlphaFold. So molecular biology has completely changed within a couple of years. Yeah. So great talk, Noshir.
Thank you. So you raise interesting questions. So my first thing about your notion about the word delve. So it just occurred to me that if we continue to do what Thomas did and to have n-grams that are going to see what's going to happen, we normally have looked at changes in n-grams as reflecting human thinking. But this may be one of the first examples of a ChatGPT-induced spike in the word delve in the n-grams that we now need to think about. Part of what I mean by algorithmically infused society, that it's not we who are using it, but the system has its own feedback now that is creating that case. I'll come back. I'll go back first to answer some of the questions that you raised as well. The publication issue, and I think that is, and the second was whether we'll replace AI or not. Both of them are in some ways related. The publication issue, I would argue, is very, very long overdue. We haven't changed the basic framework of our peer review system since the first peer-reviewed research journal, which I believe was the Royal Society. Isn't the Proceedings of the Royal Society? Is that what it's called? Yeah. That was the first peer-reviewed journal. And basically, we haven't really changed the ways in which we have published since then. Now, some could argue that why fix something if it ain't broke? On the other hand, I think there have been many more people who have talked about whether we could think about taking this journal article and making it into very small nuggets. There is, in fact, I'm blanking on his name, but there's a colleague in the Netherlands who has talked about the minimum publishing unit, which is essentially just like a claim, and to see how those can be instead looked at. It'll address the question you said about just saying, I want to just say, why do I need to have this padding? There are big disciplinary differences. There are big institutional differences. I ran a panel at the Computational Social Science conference a few years ago where I had an editor from Science who said, well, as long as you can take your entire research and collapse it into about 3 pages, you should send it to us. Then you can have everything else in the supplemental information. But you should try to distill your idea to 3 pages. And right after she got done saying that, we had an editor from the American Sociological Review. And he got up and he said, as long as you can make sure that you expand whatever you want to say to 35 pages minimum, then you should send it to our journal. And these are the kinds of disciplinary differences that we deal with across different areas. Some expect a lot of preambling. Some expect you to get cut to the chase. So I think that that's an example of a paradigm shift in the area of publication that could be huge. We have now seen open access as a mode of delivery, but that doesn't change the structure of the article itself. What we are talking about is mostly in how we deliver it, how we buy it or pay for it, etc. I love that idea, and in retrospect, I wish I had thought about that, but I think that is something definitely worth taking. The second one, I understand what you're saying, that you believe that we will not be able to, that at least for now, you don't think we're going to be replaced by the LLM. This again is a matter of looking at history. Every time we've had a new technology, and one can make the case that Gen AI is not like any other technology we've had, not even any other general purpose technology we've had. One of the things we have learned is that it means that in order for us to continue to flourish, we as humans have to think about what is called as reskilling. In other words, what is the value that I bring as a scientist if many of the things that I did as a scientist, some of them pretty tedious, can now be done much faster with Gen AI? Clearly, one of the things that's not going to go away, at least in the near future, is our ability to evaluate what it does. We've talked about hallucinations. Some people call it hallucitations. These are not going away anytime soon. And so part of what we always will have to do, at least to the best of our knowledge so far, is be the person who has the ultimate responsibility to look at whatever is being done and to curate and evaluate it for what it's worth. But I think that there may be other skills that we need to think about developing that are not easily, that are not the strengths of something that we can do with Gen AI. And again, that means our educational system has to be rethought in that way. There were times, we've already talked about this, the calculator. We spent a lot of time learning how to use a logarithmic table. Anyone here besides me use the log tables? And then we had the slide rule. And today, it doesn't mean that we don't go back and say you can't use it. I was at periods where we were told you cannot use a calculator, you cannot use this, that, and the other. But we use it, but then we now have the educational system means we're not learning as much as we did about how to use log tables, but we have new things to learn. So I do think that there is going to be a big change about how we get reskilled and how the process of what does it mean to be trained as a scientist will be changed in the presence of LLM. And then I'm trying to think about you.
Sorry, I didn't formulate it as a question, but you skipped this molecular biology part a bit.
Yeah, no, I did, and thank you for mentioning that. In part, I made the, perhaps in retrospect, mistake of saying everyone in this room knows about AlphaFold and knows about GNOME and knows about protein folding and so on. But I think that your explanation was very crisp and very good. Speaking of which, CRISPR is another example that also uses AI in ways that we could be talking about. So yes, thank you for expanding on that.
All right, thank you, Noshir, Günter, Georg, for the moment. And now let's open the discussion to the audience. I've seen already 2 hands. Please say briefly your name, third hand, and ask a question. Francesco.
Thanks. Hi, I'm Francesco Striano, visiting junior fellow in the Digital Humanism program at IWM, and I was wondering. I mean, maybe it's not so much a question, but maybe some reasoning that I'm doing about the publication issue again. Because I understand the point, but I'm from the humanities. As a philosopher, my job is basically reading and writing, hopefully also thinking a little bit in the middle. But what I observe a tendency in the humanities because of this to prohibit the use of large language models or AI tools. That I think is kind of stupid, because I agree with you that AI will not replace academics, but academics with AI will replace academics. But I think that when we finally maybe accept these AI tools also in the humanities, we have two options. I mean, or we start just to produce a lot of unuseful articles and just because we have to publish, or we can also start to publish maybe less, but thinking more. But my fear is that based on current quantitative evaluation of research, we are going to just force to produce more because they say, oh, since it is easier to write, you can publish more. And so we have even less time to think on what we are going to publish, but also less time to do proper research in hard sciences or in medicine or in other disciplines. So I think this is not only an issue about science, but also about politics and academic politics. So maybe this is also a little bit connected with the next session, maybe. It's not properly a question, but I want to ask you, what do you think about this? Thank you.
Could I respond? I think that your scenario is a perfect example of that enlargement phase that I talked about, right? Because now that you can do more, you will be expected to do more, it'll be easy to do more. But that's when I think society, or at least the scholarly community, or in your case, the humanities, has to take stock of, if this is no longer a valuable way of judging it, the quantity is not the important thing, what are other ways in which we recognize, reward, incentivize scholarship? And it was easy in the past to say, oh, well, since it's hard to write these things, let's just count the number and it'll be a handful. But now, if you've made that process so much easier, then you have to rethink what it is. And that's where the reconfiguration will come in. That's where the publication issue that you raised will come into it. So I think we should be thinking of that. And my only reason for having that substitution, enlargement, reconfiguration is I've seen us go through this without realizing that this same thing has happened in the past with so many other technologies that have come our way. So if there's any way in which we can learn from that and anticipate it, we're better off.
Yeah, I would like to add, I mean, that's why I deliberately said humanities, I think, are a completely different story. I was strictly referring to science in the hard sense, like medical sciences, for instance, performing a clinical study to prove the efficacy of a certain therapy or something. There, I think the way we write the text is secondary. It's the results, the numbers, the significance and all that. I do acknowledge that, like in philosophy and in social sciences and many others, very often the scientific work consists of new interpretations of research knowledge. There, I mean, we have a different story. I think we will need to decide how we deal with. I mean, in my view, perhaps that means that a scientist in that area, well, yeah, we'll have to raise their work on a different level. Because I believe, and that's why I mentioned creativity just before, I believe that at the moment, language models can nicely be creative in the sense of an interpolation, so they can create text which is somewhat similar to known text, but the out-of-box thinking, the complete new idea of how you look at things, that is probably not capable of, and that might be more the role of the scientist in the future.
I just add one sentence. So there is really an exponential growth of articles in some areas. Yeah.
So I'm going to help you out on the bit where Noshir, where you blanked. So the guy in the Netherlands is called Barend Mons.
Yes, exactly.
And
yes,
the name
exactly.
the name of these publications, they're called nano publications.
Nanopubs, yep, that's it.
So a
yes.
nano publication is like the super condensed version of, I mean, what you said, like, the statistics about your medical trial. And there's even, this is no longer a pipe dream. There is formalized languages in which people express these nano publications to be published on the web. There are servers in multiple countries that host collections of nano publications, which are extracted from papers. I mean, the joke is that, sort of, one of the reasons why we need to do information extraction from papers is because we first did information burial, right? So we had this information, then we buried it in text, and even worse, we buried the text in a PDF, and then we need to dig it all out again. So cut out the middleman. So that's the positive version of this story, and I go along with a lot of that. On the negative side, science is a social system. Right, and words are important in a social system. So there are very interesting studies on, say, hedging words. So scientists rarely say "this is." They say stuff like, "Oh, it seems to be the case that," or "the evidence may suggest that," and so that pushes me away from this maybe naive version of the nano publication as a bunch of facts that sum up a paper. What's your position between these two extremes, on the optimistic or the positive, and or the pessimistic view on this possibility of these nano publications?
I can go first. Thank you, Barend Mons. I feel bad. I hosted him for 2 visits at Northwestern, and so I hope he never sees this YouTube video. But he is indeed the person I was thinking of. And I know that it also has connections to semantic web, because you're able to put this...
Semantic web languages for...
Exactly. Yeah. I see the pluses sides of that. I think that your concern about the language assertions is something that can be addressed. I agree with you that we rarely in science make simple assertions of it is or it is not. We certainly in our world, at least in the social sciences, but also in behavioral sciences, we live and in the rest of the sciences, we live in a stochastic world. So by definition, we're going to say it is more likely rather than it is. Okay, simply. So I think that in that sense, I don't know whether the use of stochastic language precludes the use of making those kinds of nugget statements, as long as you hedge in that sense. And I think that everyone expects it, and it would be really weird if you didn't, because there are very few deterministic claims that anyone would want to make in any of the sciences. So I see that, but I think it is something that one has to be mindful of in terms of being able to understand how to be able to use that language. So I think I like your notion of it being that we bury the findings in it, but there is other things that are not as easy to be able to put into a semantic web structure, for example, and that's why I don't think that we will see the end of a narrative. But being able to make it easy to abstract certain associations, like some of the examples that I was saying, are definitely much more needed now, exactly because we have tools from GenAI that allow us to process a large number of them as compared to what any human being, or God forbid, a graduate student would have had to do in the past.
I would also like to thank you. I wasn't aware that that community already exists. Yeah. Thank you very much. A big learning effect for me, and sees that the reconfiguration effect is already working. But I also agree with you. I mean, that's not all there is to science. It's a social thing. We exchange ideas. We sit here. I mean, if here at this meeting we would all read statements generated by ChatGPT, we wouldn't by far learn as much as we are by exchanging our own opinions. And I think we shouldn't overlook that and see that this is being preserved.
George?
Thanks to all three for all these wonderful insights. 2 historical remarks and a question. To all three. Historical remarks is that you said electricity took more than 40 years to be broadly adopted, which is true. But studies have shown that the main reason it was that it was restricted to lighting, no appliances. And the reason that there were no appliances were safety. People were electrocuted, they died. The harms of generative AI are less measurable than electrocution. So there were some different contexts there. The second historical remark is an article by my diasporic compatriot Nicolas Negroponte of 40 years ago, who argued that smart refrigerators would never make money, and they never did.
Not yet.
And here comes the question. I think when we study the impact on scientific research, it would indeed serve us well, as was mentioned by the panel, to separate what area we're talking about. I don't know anybody I would like to talk with that would dispute the wonderful value of AlphaFold. And certainly, you know, that it proves the maxim that with that tool, you're much better than without it. But however, but not to be polemic, but if a sociologist studies using AI tools, data generated by AI effects on society, there seems to me that there's a danger of a recursion effect. So that, for example, if you do that, I mean, you look at the world and you study it. If another sociologist looks at a different world that includes you in it, there's a sort of underlying Gödel's theorem somewhere there, I don't know where.
So thank you, George. As always, very good insights, both historically and otherwise. I think that the issue about the electricity, the first point you were making, I think is good. And I think part of it is what was being argued, that any general purpose technology really doesn't take off until a whole ensemble of different infrastructure can come to play. Those ensembles are coming to play much quicker now than they did at the time of electricity. And so, but it doesn't mean that it doesn't have to happen. You still need to have that whole ecosystem that needs to be in place in order for some of these general purpose technologies to take off, but they contribute to it. And so what you've seen is that in the speed up of that entire process is happening much quicker now than it did previously. The second point that you made, polemic or otherwise, to me sounds like a regurgitation of Heisenberg's uncertainty principle. It's basically saying that the act of observing is going to change what is being observed. The social sciences have known that all the time. It's made much more complicated when you have algorithms that are hidden, that are also now part of that Heisenberg uncertainty principle. But surely you're not suggesting that because we have this, that we should abandon the ability to, or we don't see the utility of using Gen AI to further interrogate social systems that might have embedded in it this Heisenberg uncertainty quality.
I argue that we do it with tempered optimism.
Oh, okay. Well, I think that that's fair. That we have to recognize that we are going to have certain, we have to put certain caveats around the work that we do, and it could vary from different contexts, not only from one context to another, but from one time period to another. But at the same time, I think that there is enough insight, especially because of the implications for policy, that and for different parts of our community, especially those who are underrepresented, that we need to be able to do the best claims we can in all of social sciences, not just sociology, and that saying that means we can't get definitive results means it's throwing the baby out with the bathwater.
Two quick comments. So I liked especially what you said about the electricity and uptake of electricity. I didn't know that, but also here I see an analogy. So in order for electricity, we all have the norms now. I don't know all the English words about, so all the regulations around electricity. And now we're also building all the regulations for AI. Of course, it's on a much faster scale, but it seems that there's an analogy also here. And also on the second thing I wanted to comment. So what if now this recursion that you mentioned. So the generative AI generates text, images, and then the next generation will be trained on that. Yes, and there's also really technical papers that you try to train a neural network on text, for example, that it produces itself. And if there is very little, if it just learns on its own output, it can diverge into any very strange thing. So it can generate gibberish language that and you so something that you cannot work with, and then it doesn't improve itself in that way, but it kind of goes or converges to something very chaotic. So it's trained on human content, and I think at some point we will see the text that is generated. So we will look back and say, okay, we can use the text from 4000 BC until November 2022, which will be guaranteed to be trained to be written by humans, and from November 22 on, there might be a lot of AI-generated content which is less usable or less reliable. So this will be quite the mark. And I think that's also already what is done, that when large language models are trained, that there's a lot of effort now to have high-quality data, curated data, and so on, in order to avoid that a neural network learns on its own outputs.
Two additional facets to this problem. The one is in medical data, of course, as was mentioned, we have to deal with data protection. It just has very sensitive data. So there's a lot of discussion now of whether we cannot generate data that looks like real images, but is not a particular personal image, and then do our research work with that data. So that's the positive side. On the negative side, I think many researchers, and Günter knows more about that, use also those techniques of generating data to augment, to make their data sets bigger. And I always have a little knot in my stomach. I always worry if we seemingly increase our data that we then do research on, that we don't perpetuate something in there. So exactly as you said. So there's a positive and negative facet in my view.
Günter, is that what they call drifting? When there was a term that became popular a few...
drift effects, yeah, that's a bit different. So drift effects is more when you put I've heard that in different contexts, but when you put an AI system into production, and usually you have tests and say there is a certain accuracy, and then you put it into production and you see over time it decreases, and that's a drift effect, because usually then the way how people interact, so there's some distribution change, and therefore also the performance changes.
It is a recursion effect in a sense.
It is in a sense, yeah.
There's also the term of model collapse, no?
That mode collapse is more if we really train it out, that can happen, that it's the generative AI, we want to somehow get some diversity, although that is questionable anyway, but a mode collapse happens also when training, that it outputs, for example, only a single image or a single sentence and so on. Yeah.
Okay, Helga Novotny.
Yeah. Thank you. I would like to come back to what you said about reconfiguration, and you talked mainly about the publication system and the way how it changes the way how we work. Now, you also mentioned, and I fully support this, that our publication system has not changed since, centuries, you could say. And I would argue it has been more than overdue for a radical change. So everything that AI does right now, is vastly overdue. And we see it in the publication system in the way how we have first author, second author, etc., has to do with a lot of other things. Now, and this will also happen to universities. The way how we teach, it's long overdue. Our school system, if you think of education, the world around us has changed in so many ways. What has not changed is you go into a classroom and how we teach and how we learn. So AI comes at the moment where things that we have taken for granted just will fall apart. And it has to be reconfigured because, it will go on. But I would like to touch on something that you have not mentioned. And this has to do with the automation. And we see automated labs, It will be a big change, of course, because of the rapidity in which this happens. It has many positive effects. You can now federate labs around the world because they're all automated. So, for environmental science, many other fields, will have many positive effects. But, of course, it also raises the question, how many PhDs will we need in the future, the more we automate labs? And on the discussion that you have about the replacement of, jobs in society, we all agree new jobs will arise, others will disappear, but nobody can tell you how fast it will happen. And will the new jobs come in time, or will we have some, period which will be rather unpleasant? And the number of PhDs and how we train our PhD students for what is also an important question. And another issue, because you mentioned social sciences and synthetic users and so on. And there I see, it's sort of almost the equivalent to automation in the lab. You have a sort of synthetic, you have a digital twin of society, and you go down to the micro level, so you have synthetic users. And we also know the data come from the past. And what are we losing out? And we see the tendency towards, we spoke about it before, the averaging, yeah? You lose out what happens at the edges. You lose out the outliers. And yet the social dynamics of society very much depend on what happens at the edges. And outliers, they start very small, but they tend to grow. And then you have the dynamic change, and then we say, how could it happen? And much of what we see in society today that we thought would not be possible just a few years ago, it's there. So I'm just saying, don't go too far in relying on this kind of synthetic world.
Well, thank you. First of all, great comments and on point, and it underscores my failure in perhaps spending as much time on the caution side of it than on the optimism side of it. So almost all of these issues that you mentioned I had included in, but perhaps not underscored, right? The average, not the distribution. The fact that it only worked, like the Ukrainian case, it only worked on the past data. I think one of the questions is that these, I highlighted those because they are real limitations. Now, are these limitations of the current model that somehow a new and improved model would fit, or is it a fundamental deficiency of these models? I suspect it, and I think you would agree, it's probably the latter, not the former. It's not that you can just fix it by doing a better Gen AI model. And so as a result, again, it ironically addresses the first question. Humans are not going away. There are things that are still being able, that only humans are capable of doing, and only human respondents are capable of answering in a survey as opposed to synthetic users. So I think that we need to be very strategic in recognizing where we are able to leverage the automation, where we are able to leverage the enlargement of these activities, but be also very cautious about where that doesn't happen and the implications of that for training students. It may be that we need fewer graduate students. It may mean that we need fewer scientists. I don't think that's the case, because I think, maybe this is my optimistic side, that there'll be new avenues and areas of science, so that even if in a particular area there may be fewer needed, but there may be other areas. Let me tell you something I didn't talk about either that I thought you were going to mention, and that is our entire research funding process that you may know a little about, right? That whole process is also pretty antiquated in its own way. You could say that, in the Renaissance, there was patronage of the Medici families and things of that kind, and now the patronage comes from federal funding agencies and corporations. But that, again, is in large part, and especially given what's happening with Gen AI now being so heavily dominated by industry, we have to think about what this means in terms of funding, about how it happens in universities or elsewhere. I think that there is a reason to believe that these efforts, you said we don't know when the new jobs will come. I don't think that I wouldn't look at it as binary. I don't think that we are suddenly going to be told one day, you're out of a job. It just means that we are gradually having to redefine some of what we are doing out there. And so that I'm not as fearful as in some previous generations where a mechanical device came and your boss told you, I don't need you anymore. I've got this robot who's going to make the burgers in the fast food restaurant. I don't see it quite as binary as that. And so I think that we have some time, but if we don't think and anticipate these issues, we may get to that point, unfortunately.
Yeah, Stefan Klein.
Stefan Klein, Universität Münster. I'd like to ask a hypothetical question with two facets. Assume your publisher would sell the data that you have produced, your work, to OpenAI and monetize, in a way, what you have produced. Because this is what's happening right now. As you know, sort of big publishers are selling data to these Gen AI companies. So the first is the economic one. The second is assume now that the data and the work you have produced is being used in the Gen AI and the LLM without reference to you as an author. And I know there are ways of referencing, I'm aware of that, but assume that you are not referenced. Would you be happy about that? Do you think that might be a problem or not?
Yeah, I'll jump in. So I think that's a huge problem, and there are also not only scientific works, of course, there are really copyright cases now filed against OpenAI and so on, because it obviously uses copyrighted materials. I think that's a huge problem that they just train on everything. Yeah, also the publishing system, even without AI, it's a bit strange if you think about it. So you do the work, you get public money, you do the scientific work, then you give it to a scientific publisher. You might even pay for open access, and they get a lot of money for it. So that's, I think even without AI, it's strange. Yes, but overall, I think there has to be, we're giving a lot to the IT giants, right? We see OpenAI training models, Facebook, Meta training the models on this data. And then when something goes wrong or when it doesn't output something, it says, according to the guidelines by OpenAI or by Meta AI, it doesn't, blah, blah, blah. It's not possible to answer this question. So we are, I mean, we have much stronger legal bodies, right? So we have the, in Europe, we have legislation, we have Austrian legislation, we have human rights, and this should all be way above the OpenAI guidelines, right? So I think there's what we're giving away is basically completely what it's the training corpus on what corpus it should be trained, the training data, and we're giving also away some guidelines it should adhere to, and so I do think that it should be somehow, there should be some kind of democratic process behind selecting training data and training a model on that. So I think there are extremely fundamental problems far beyond. I mean, I cannot solve it. Obviously, I'm unhappy that it is trained. And I'm also seeing all the subsequent problems. But yeah, there is no easy solution, I would say, and it would be, I think, it would mean that we have to make a large-scale effort to come up with some democratic way to decide on the training data and to commonly train a large language model and decide on which guidelines it should adhere to.
If I may add. I may add a couple of comments as food for thought and to counterbalance this a little bit. First of all, publishers give away only information that's already public, whether you have to pay for it or not. It's public in the sense of publication. So it would be much more critical if there was information that's really confidential and not meant for the public. Secondly, if we plan or would think about prohibiting large language models being trained by that data, then in consequence, one would have to prohibit us all scientists to read those papers, because we also absorb the data and perhaps later cite something from it without remembering where it was from. So that's exactly what happens in an LLM. It's a condensed version of all this different. It's not in only few cases. It's a literal word-by-word citation. And thirdly, latest models that I know, not only ChatGPT 01, but also Elicit, Cite, and all these other models that use LLMs, they are capable of proper citing now. I mean, they give sources and they cite papers, and so we're stepping in that direction that proper credit, I think, is being given to those who originate some information.
I just add very briefly to this. I think this is an important issue. I don't think that if you ask me as in a hypothetical question, it's not a hypothetical question. At least I know that in my field, in the field of communication, for example, that our publishers have signed deals and have notified us in some cases after the fact, which did not sit well with some of my colleagues who were not consulted before that. The question at this point is not whether it's going to happen. I think it is probably going to get cited. The question is not just whether we get credit for it in a citation, but where is the financial model and the business model? Think about what happened when Google got into trouble in Australia and a few other countries where they were told, you cannot be showing results from the New York Times and other places, right? And like the New York Times is suing OpenAI for the same thing right now. And one of the reasons why Sora was released and then immediately taken back in the last 48 hours, 72 hours, was because the creative industries had the same issue, that it's not just about scientists, it's also about artists who are concerned about these issues. I think what has to happen is at two levels. One is the regulation, the EU and others who need to put guardrails on what can be done legally. And then the second, and how much of transparency there should be in that. And then the second is, I think, there's a compensation issue here. And I can see, for example, professional associations, whether it's the ACM or whether it's others that I've been involved with, which would say, look, if you want to sell this, then you need to share some of those profits back with the people who are managing these journals or helping do work on these journals. I have to say that in one case at least, I was told that the publisher had really given away a lot of this data for a pittance to these LLMs, which makes me mad because if they had negotiated a better deal, we could negotiate a better deal than with the publishers as scientists. But this is all still very much in flux. But I think that it's not hypothetical, it's happening.
Okay, so I take the authority for the last question. I mean, we talked quite a lot about machine learning or data-driven AI. And when it comes to different disciplines, and now we have 3 examples, I mean, data is not equal data. There are different levels of, say, sensibility, maybe of availability. In medicine, there are stricter regulations compared to social science, maybe, and with proteins, maybe it's not so problematic. So what is this impact? So is it maybe that some disciplines are now in a disadvantage because data is not so easily available? Is this something we have to take into account? That would be my final question.
My first answer would be yes, because I mean, machine learning is a statistical technique, and more data means better performance, and we all know about the bias in many of that system. So yes, it will result to some areas being in a disadvantage. Also within, medicine, we would like to have models for prediction or something for which we simply don't have the data yet, and so we have to wait for the future. So yeah, it's certainly a problem that will need to be addressed, yes.
We clearly see a tendency, of course, there's a lot of scientific papers in these areas of natural language processing, in computer vision, and for the proteins, I think the PDB is also relates to the last question about access and so on. So the PDB, I think there's an estimate that it costs to build this up $30 billion. And so there's a lot of effort by scientists put in to build up this database, and now it's publicly available, and they train AlphaFold on it, and now they also have commercial versions of AlphaFold where they profit from. So that also implies that. So, but yes, now we see a lot of differences between the disciplines, and that relates also to how much data-driven approaches are picked up and used, and it's unclear how there is some process in other disciplines now that were less data-driven, how to build up reliable data sets for machine learning. So it also drives some scientific process, but of course some will always have this disadvantage either of data availability, accessibility, and of methods. And there's also some other domains have differently structured data, so not something that you can squeeze in a sequence or in an image. And this also sparks some methodological advancement, right? You have something where you have graphs, and you have to develop neural networks that work on graphs. They are there, but something like this. So it's I think there are different sides from this, but there's definitely a lot of diversity concerning data and availability.
So some of you probably have heard of the story of the person who was drunk and had lost the keys to his car and was looking for it right under the lamppost. And someone said, why did you lose your keys? Where did you lose it? He goes, I don't know. He goes, why are you looking here? He says, because that's where the light is. And I think we face that with a lot of the places where we go do work where the data is. Right? If we have a lot of data, we'll go do it there because that's where the data is. And I think that comes at a price because there are a lot of other areas that we are now neglecting simply because we don't have at least what is called as just the digital trace, or some people call it digital exhaust data, one kind or another, or where it is relatively easy to instrument to be able to get the data. However, I think there is an argument to be made that, you began to touch on what part of that, and that is data doesn't always come in the form of quant numbers or vision, etc. There's a lot, especially in the humanities and social sciences, there's a lot of data that can be looked at from very different ways. And it doesn't have to be data-driven. We've talked back and forth during the conference so far about theory-driven versus data-driven. And we had the articles, I think was even referenced here, the end of theory that was mentioned by the editor of Wired magazine. And do we need theory when we can have the entire model and do everything, etc.? I think that balance has to be tempered again, or we need to put that back into the equation. Because the old ways in which we often did theory-driven work was we started with theories, we decided what specific data we wanted to collect, and then we're able to try to find where that data could be and how it could be collected. We moved away from that because of this abundance of data that is there all around. But it's unequally, it's not uniformly distributed. And so we have certain areas where we have a lot of data, and we've rushed into those areas. But I think we still need to be able to uphold the idea of what it means to do what some people have called, intentionally being able to design projects where we can say narrowly what data we need. And yes, there are a lot of people, machine learning in general may not be good for some of these, though there is also a lot of work done in statistics looking at highly unlikely events and modeling very unlikely events. And that area of research has actually also been doing quite well. There are lots of groups in Stanford who are working on that. And I think that is partly because you can't expect a lot of data in every area.
I hope there's time, but there's a very cool story. Okay, very briefly, Stanford, there was a group working on medical images, on ophthalmology, retinal fundus, and they tried to predict cardiovascular risk factors, right? So they had a lot of data, medical images, predicted age and so on, because these are all risk factors. And suddenly, much disputed, they also predicted gender, okay? It's obviously a risk factor for cardiovascular diseases, but suddenly they found out there's a 99% accuracy in predicting gender from the retinal fundus image. Okay, you can shrug because gender is easy to determine, but the important thing was no ophthalmologists in the world knew that there was a difference between men and women concerning the retinal fundus. So they suddenly found out features in the retinal fundus images that were different between men and women. So new medical knowledge was generated that you can now put in the textbook. So it's how the blood vessels were. New medical knowledge was generated without an hypothesis, purely data-driven. So that completely changed how science works. Yeah.
Okay.
Sorry.
So I think we should come for the coffee now, Enrico. No, there was another week before. So if I take yours, I take another one, and maybe then someone else has a question. But I don't. So it's up. People are to.
So everyone. Yeah. So
coffee break.
So yeah. So I'm a physicist and quantum scientist. One of the for me in science is that the key point of science is to make predictions that are far outside the data that I have. Yeah? Up to now, we had discussed most of it, that use the data and do something within that. And this is for the science. I think this is, for me, the key point of science, to do predictions that are very, very far out away from all the data that I have, from which I do the conclusions. I make something that has a predictive power that goes much, much far out from the region of the data that I have.
Not just out of sample. You're talking about
really
distribution.
Yeah.
I would just to...
Not out of a sample, just really allows you to make really very far predictions in completely different domains.
Yeah, just about the quantity of data, I would like to repeat a remark that I made this morning, that we have to be careful about the large amount of data. Because, and this is a theorem, mathematical theorem, if you have a large enough quantity of data, you can find any correlation whatsoever, even if data have been randomly generated. So this is the importance of having a good theory in looking in data. Otherwise, you will find complete falsity.
I just quickly, yes, that is true. That's why p-hacking has become such a big issue, where you can look for correlations by chance. But one of the things that methodologists have done in response to that is not just look for significance, but look for effect sizes, because you can have something that is statistically significant, but substantively the effect size is so marginal that it's meaningless. So at least to the best of my knowledge, that's one effort made by people who are looking at large data sets, not to rely any longer on just statistical significance because of the reason you said.
Yeah. Okay, so based on past data, I have a theory. That is, we should have coffee now, but let's first thank Noshir, Georg, and Günter for their inputs and also for their questions. Thank you.
Great.